All right, let's talk about example 4. Dr. Mike recorded the average population of the shoppers at a new coffee shop over a period of days following its opening. The data from the study was plotted, and a Quintic regression was used to generate the polynomial function to best represent the data. All right, so part A says, according to the Quintic regression, during what days of the study were the most shoppers there, and approximately how many shoppers were there? Okay, so a couple of things. If we look at our X and Y axes, so X axis is the day, all right, so day 0 and then all the way up to day 100. And then it says the number of shoppers in hundreds, okay? So if you look at the data and you're like, wait a minute, how can there be 1.5 people? Well, there weren't 1.5. 1.5 would represent 150, or 2.5 is 250. All right, so make sure you're understanding how that works for this particular problem. So what day of the studies were there the most shoppers? Well, and we also want to pay attention, we're dealing with the Quintic regression, so that's going to be the line, not the little blue open circles, okay? So if I were to highlight the line here, this is what we're focusing on. I think you can just barely see me highlighting it here, I think. There we go. All right. So that's the focus for part A, is according to that regression, where were the most shoppers? And basically, well, look for the highest point. So we're up here. All right. And what we want to look at is if I go to the very highest point here, and then come on back down to the x-axis, I'm going to say day 86 or 87, okay? So day 86 or 87, and approximately how many shoppers were there? Approximately, I'm just going to use the wavy little equal sign. So let's see, if I'm here and then I go across, let's say about 360 shoppers. Okay, it's all approximates, so keep it close. Okay, during what day or days of the study were the number of shoppers predicted by the Quintic function unreasonable? Well, I don't own any kind of a coffee shop, but I am pretty sure that you can't have negative people. All right, so we start with the negative right here, we end with the negative right here. So I would say between, all right, so between day, let's see, I'd say like 37 maybe, and day, let's see where we're at in this part. Let's go day 50. Okay. The number of shoppers predicted is negative. Okay. Predicted shoppers is negative. Yeah, okay. Which, hold on a second, which is unreasonable. And so this is where we talk about modeling functions and we talk about modeling real world things. Sometimes the models don't make sense in the context of the problem. It doesn't make sense to talk about, oh yeah, on day 42, you're going to have negative 10 shoppers. Well, that doesn't make any sense. All right. And so if that's the case, that's definitely unreasonable. All right, let's see what the next question is. According to the Quintic regression, during which days were the number of shoppers increasing? All right. So if we look at our function, all right, so from day 0 all the way up here, what is that, about day 18, 19. All right, so that's going to be the first part here. So from day 0 to day, I'll go 18. And where else? Now, this is according to the regression, so it might be unreasonable, but basically at the very lowest point here, we go from decreasing to increasing. So I'd say it was about day 45 to day, where are we at up here? 87, 88. Let's go there. All right. And hold on a second. From day 45 to day 87. Okay. So those were two different time intervals. Basically, you would be looking at from 0 to 18 and then from 45 to 87. Okay. All right, using the Quintic regression, determine the average rate of change over the interval 60 to 80. So this is going to be an approximation, all right? We're going to have to basically estimate, and that's okay. So let's see, at 60, so let's see, 60 is right here. I'm going to pop up. I'm going to hit my x-axis. Nope. Let's see, that is the x-axis. And then if I go over, I'm going to say that's maybe 60 and let's say 125-ish. All right, so 60, 125. And then the other half of the graph is 80. So let's see here. 80 is right here. So let's go all the way up and then go all the way over. How about 360? All right, so 80, 360. All right, so average rate of change here, we're going to take one of our y values. We are going to subtract the other y value, and then we want to make sure we mirror our x values. So that's going to be 80 minus 60. All right, so let's see, 360 minus 120. I'm just going to grab my calculator, it's sitting next to me. That's 235, and 80 minus 60 should be 20. So if I divide 235 by 20, I'm going to get about 12. All right. I'm going to go ahead and, yeah, I rounded out my answer. That's all right. Okay. So explain the meaning. So this would be from day 60 to day 80, the average number of shoppers was increasing by 120 shoppers per day. All right. Now, remember that this is at the very beginning, right? We were talking about the shoppers in hundreds. So, oh no, I already did that part. Hold on. All right. This isn't 120 shoppers. It is actually 12 shoppers per day. The reason I had to think about that was when I took my ordered pairs, I had already changed these into hundreds. I didn't use 1.25 and 3.6. So this actually does represent 12 shoppers per day. Had to think about that for a second. Sorry about that. So clearly, right, it's definitely one of those things to pay attention to what's going on with the x-axis and y-axis. Because, well, you know, we make mistakes every once in a while. So that one should be 106. So 60 to day 80, average number of shoppers was increasing by 12 shoppers per day, not 120. Sorry about that. All right, so that's the end of example number, I think I forgot which one we're on. So number 4, I think. What is this one? Yep, example number 4. I've got a couple more examples to go through. As always, if you have questions or concerns, let me know how I can help.